Okay, this is question 63. A non-rotating cylindrical disk of moment of inertia is dropped onto an identical disk rotating at an angular speed omega. Assuming no external torques, what is the final common angular speed of the two disks? So we first need to find the equation on the equation sheet. And so this one is the one that we need because L is angular momentum, I is the rotational inertia, and then omega is angular speed. So we want this equation. So we have two disks, disk 1 and disk 2. Both of them we will put into the angular momentum equation and labeling inertia as 1 and 2. And one of them is non-rotating as stated in the problem. And so we'll make disk 1 non-rotating. And if it's non-rotating, that means that the angular velocity has to be 0 because it's not moving. And so that would just equal 0 because anything times 0 is 0. And then we want to find the common angular speed of the two disks. So we have to put these two things together. So L equals I1 plus I2, and then the omega will be final angular velocity. And we can change this L to I omega because we want to find the final angular velocity of the two disks. And we have inertia 1 and inertia 2, and to get rid of that, since the disks are identical, the two inertias are also identical, so that means I1 plus I2 is just 2I. And so I1 equals 2I times final angular velocity. We can get rid of these inertias, and we're left with angular velocity times equals 2 times final angular velocity. And since we just want this by itself, we can divide it by 2. And then we get final angular velocity equals half times omega. And this is the answer.